All right, so these are the things I'm going to need you to do today, because these are the things that we've been talking about for the last couple days, figuring out, learning, all that kind of stuff, okay? Now, notice these top 3 steps, there's a box over here that says how. There's not enough room in this box to describe exactly how to do each and every single one of these steps, but we want to give ourselves enough of a reminder, even if it's just 1 word or 2 words or 3 words, enough of a reminder how do we start each step. Are you okay with that? So which one of these are you very confident that you know how to do? You know how to do horizontal asymptotes? Okay, what do you do? Look at the what? For horizontal asymptotes, what do we look at? The exponents, specifically the degree. Right? We look at the degrees. Now there's other stuff we do. Remember from our worksheet from the other day, we look at the degrees. We decide if the numerator is greater or if they're the same or if the denominator is greater, and based on that we know what our horizontal asymptote is, right? Okay? So do you see what I'm saying? This is going to give us a start, reminding us what to do for each step. Okay? Now which one are you confident that you know how to do? Vertical? Oh, discontinuity? Okay, how do you do discontinuity? Close. You do that eventually, but it's not the very first thing you do. What's the very first thing you do? Factor. Now, you guys are all telling me good things. I'm not trying to discount what you're telling me because you're all telling me exactly what to do, right? After we factor, we look and see what factors in the numerator and the denominator. We're just writing the first step so we know what to do first, and then we remember from there. Yes? Good job. Okay, what about vertical asymptotes then? That's the last one. Uh-huh. Oh no. N-O-M. Pretend that's an N, and pretend that's an M. Or we could just call it denominator from now on. Denominator. Denominator. Okay, I'm okay with that. Why did you change it? Because we couldn't spell it. Okay. And by we, I mean me. I'm the one that spelled it wrong. Okay, good catch though. All right, after that, we need to draw the asymptotes. We don't really need to help with that and knowing how because we were just drawing. Making a table, we know how to make a table. Plot the points, we know how to plot the points. Identify domain and range, we know how to do that. That's why there's no how boxes down here. Okay? So let's look at number 5. Now, the other thing I want you to keep in mind is this is not necessarily the order you have to do these things in either. Not at all. Okay? There are some things that we don't want to do first. We probably don't want to do vertical asymptotes first, right? Because we really kind of need to do discontinuity before that so we know where the vertical asymptotes are, right? So what do you want to do first? So the horizontal asymptotes. Okay, that's fine with me. If we're doing horizontal asymptotes first, what do we need to do? Yeah, just reminding ourselves we're looking at the degree, right, for horizontal asymptotes. So what's the degree of the numerator? 2. What's the degree of the denominator? 3. According to our chart, wait, which one is greater? The denominator is greater. If the denominator is greater, does it have a horizontal asymptote? Yes, and where is it? Oh, try again. Y equals 0. Very good. Okay, so we have a horizontal asymptote at y equals 0. Are you guys okay with the fact that I go ahead and draw that horizontal asymptote on my graph? Okay. Just trying to save myself some steps later. It's not required to do it now. Okay? Now what? Discontinuity? Okay, how do we do discontinuity? Factor. So let's factor the numerator. How about plus 3 and minus 2? What multiplies to be negative 6 and adds to be positive 1? Positive 3, negative 2, right? What about denominator? Well, first of all, do you notice that each of these terms have an x? So what if I factor that x out first? Don't I have x squared plus 3x minus 10? Well, I know that that factors to x plus 5 and x minus 2, don't I? Okay, so far? How did I get this x? They all have an x, and I wanted to get that x out of there before I started other factoring. Okay? Then I could have written it down. I didn't. I just imagined that this was x squared plus 3x minus 10. And I can factor that the same way I did the one above it. What multiplies to be negative 10 and adds to be positive 3? And that was positive 5 and negative 2. So now that I have it factored, what am I looking for? I am looking for the discontinuity, which is why I factored, but now what do I look for? The ones that are the same. Do you see neither that are the same? If there's not any the same, there's not a point of discontinuity. Okay? If these two are the same, what does that mean as far as my point of discontinuity goes?
X equals 2.
X equals 2. Perfect. Could I actually go in and find the point? I could plug x in.
Yeah, sure.
Yeah, I could, right? What's left? Vertical asymptotes. Where are they?
In front of the x.
What?
Don't you look in front of your x?
Set the denominator equal to 0. So do I set this one equal to 0? No, I already took care of that with the discontinuity, right? So do I set this equal to 0? So x equals negative 5. Is that it?
No.
Why not?
Because
There's an x in front. What if I set that equal to 0? What's that? X equal what? If I set this equal to 0, what do I get? X equals 0. I know. Of course it is. Also, I'm going to go ahead and draw these in while we're at it. I've got an x equals 2. Oh, that's a discontinuity, right? I would really need to know where that point actually is. Okay? So what I could do is go on my calculator, on my table, Control T, and look it up. Except I can't, right? Because what's going to happen at 2?
it's going to error.
It's an error. It's undefined, right? So I can't do it that way. There's a hole there, right? But can I go ahead and just draw a hole right on 2 right now? I don't know what my graph looks like, but I know wherever my graph is, there's a hole there. So if my graph goes way up here, the hole is way up here. If my graph goes down here, the hole is way down here. So really, I kind of have to wait till I draw my graph to put the hole in, don't I? Okay, so that's not something I can do right now. What about the greens? The vertical asymptotes, can I put those in? So I've got one at negative 5. And I've got one at 0. Because those both cross the x-axis at 5 and at 0. Do you have to wait to do domain and range until you graph? Or do you have enough information right now to tell me where the domain is? What I do know is where the domain is not, don't I? Where is the domain not? It's not at negative 5. It's not at 0. And it's not at 2. Okay? So we can say it starts at negative infinity and stops at negative 5. And then again, it starts at negative 5 and stops at 0. And then again, it starts at 0 and goes to 2. And then again, it starts to 2 and goes to infinity. Wow, that's a mess. Was that so super hard? No, that wasn't super hard. I know where the domain is not. I just have to line it up in the right order. I made sure I went from least to greatest, negative 5 to 0 to 2. I know you would rather just put negative infinity to positive infinity. I know you would rather put all real numbers except negative 5, 0, and 2, but we are not lazy. We are mathematicians. We do it the right way. Okay? Ask me. Mm-hmm. Yep. What about the range?
Is it?
Say it. What you got?
I don't know. I'm really bad at range.
It's all right.
Well, it's not. I was thinking so it'd be like infinity or zero to infinity.
Okay, so you're saying either negative infinity to infinity, or you're saying negative infinity to 0, and then again from 0 to infinity. Those are the two things I heard from you. Don't write these down yet. Let's just talk about it. Those are both of the things I heard from you. Does anybody have any thoughts on either one of those? You think the bottom one? Okay, we're gonna pause. We're gonna pause for a minute. Okay, we're gonna put this question on hold for just a second and do the table and the graph, and then we will come back to this. You okay with that? Okay. So I just happen to have a handy dandy graph already pulled up and a table already pulled up. But I want to read my directions again and make sure I'm doing this right. Make a table of important values. What does that mean, important values? So my favorite number is 13, so I need to have that on the table. Is that what it's saying? No, important in this particular problem, right? If I'm choosing x values, what kind of x values do I want to choose? I probably want to choose numbers that are around my asymptotes and around my point of discontinuity, don't I? Okay, so if I'm choosing that, then I really want to choose like -6, -5, -4, right? And then -1, 0, 1. And then, oh look, that's at 2, so I can just add 0, 1, 2, and 3. Oh my gosh, I just added a number to the table when there wasn't any more room. You're leaving? All right, get out. I'm just teasing. Okay, is that okay? Are you okay with that? Okay. Sometimes we need a little bit more. Sometimes we think there are more important points than they give us room for. Okay? But what if I only had -6, -5, and -4, and then maybe like -1 and 0? There's 2 empty spaces. Do I really want to fill up the table? Yeah, the more information we have, the better, right? Okay, so like I said, I have my table and graph pulled up, so I will go ahead and read these off for you if that's okay. -6 is -0.5. What's -5? It says undefined, right? Did you expect that? Good. Do you expect any other undefineds on this table? Where? 2 and 0? I'm going to go ahead and fill those in and we'll check them as we go, right? They should be undefined on the table. If x is -4, y is 0.25. If x is -1, y is -0.5. Oh, yes, it's undefined. Yes. 1 is -0.67. 6 repeating, but I'll go ahead and put 6, 7. 2 undefined. Yes. 3.25. Or 1/4. Okay? Now I'm going to plot that on this graph over here. -6, -0.5. Excuse me. -5 is undefined, so I have my asymptote there. -4 is 0.25. -1 is 0.5. -0.5, excuse me. 0 is undefined. 1 is 2/3 or 0.6, repeating. 2 is undefined, and 3 is 0.25. That's a good question. Why does it look like that? Because that looks really goofy.
Because
I'm going to hit Control T to get my table to go away so we have a better picture of what it looks like. Guys, on a graph like this, I have, 9 points here, 8 points here. Is that really good enough to give me an accurate picture of what's happening? No. Okay? So now that I know by looking at the graph what's happening, I can go ahead and draw it. Oh, I got to be careful though, right? When I do this side. Like that, right? I gotta have that hole in there, the point of discontinuity, don't I? Ask me. There's three asymptotes, well, excuse me, there's two asymptotes because there's two vertical asymptotes, and there's one hole because there's one point of discontinuity. But absolutely, there are three things happening because there are three undefineds in the table, yes.
So whenever there's one undefined, that means it's a line that's a little.
You either have one asymptote or you have one hole, if there's one undefined in the table. Not necessarily, but maybe. It doesn't always work that way, but maybe.
Is that range right?
That's what we're going to talk about now. I wanted to finish the graph and the table first. Now we got to go back and talk about the range. Remember, are you allowed to ever cross a vertical asymptote? Never, right? Are you allowed to cross a horizontal asymptote, though? Yes. Okay. You're allowed to cross a horizontal asymptote. You can't cross vertical ones, but you're allowed to cross horizontal ones. So, which one of these ranges is correct? Think about it this way. Will this ever cross the asymptote of 0? Will this one ever cross the asymptote of 0? So that's why this one makes sense, right? Because if we're talking about the outer behavior, the left behavior and the right behavior, neither one of these are ever going to get to 0, are they? But look what happens in the middle. Because there's a middle section, did it cross at 0? Yeah. Okay? No. The range happened to be negative infinity to infinity on this particular problem because of this situation that happened here. If that situation wasn't there at all, if this like asymptote, if I folded the paper over so those asymptotes were like touching, I'll just go ahead and do that. So it was like this. What's the range then? This one, the second one. Okay? You just have to pay attention to which situation that you're talking about. Any questions about this? Does that make it hard? No, you just have to think, right? You just got to take some time and concentrate on what's going on. Okay? So I did one for you, so 5 for you. So you need to do 1 through 4 before you get to class tomorrow. And come and ask me questions if you need help. I do have my answer key up if you need to check as you go. Questions?